In this video, we're going to talk about the kinematics of particles. Now, kinematics of particles is an aspect of mathematics that deals with the geometry of the motion particle. Now, it is a parametric function whose position vector is given as r equals xi plus yi plus zk. Now this is position and it is in meters. Now we must note that whenever we differentiate exponential kt, we're going to have, that's if we differentiate it with respect to x, we're going to have k exponential kt. Now, for us to deal with this, we need to have a good background on differentiation and integration, because the formulas really need that. For example, if I need position, I want to calculate for position or displacement r, and let's say it is with respect to t. It is given as this. We've already seen that. Now, but if I need something like velocity, let's call it v bar with respect to time. It is, I will need to differentiate the position with respect to time. So because velocity is displacement over time, or distance over time, or position over time. If I need acceleration, I want to calculate acceleration. Let's use a bar for it. Acceleration with respect to time. It is dv over dt. I will need to differentiate velocity with respect to time, or I will differentiate r twice because this is already this. So I will need to differentiate this twice. So if I differentiate this twice, then I will get acceleration. But if I need component velocity, let's say component velocity, let's use this to denote it, and it is a function of time, I will get that as v bar with respect to t dot the unit vector or the direction. So because this is because you can recall that the unit vector is given as the vector itself over the magnitude of that vector. So if we need component acceleration, a lot of other formulas. Let's see, for example, we have a question that says a particle moves along the curve x equal to 2, 3 cubed, y equals t cubed minus 3t squared, z is equal to t squared minus 4. Now, where t is the time, find the component of its velocity, at t equals 2 seconds in the direction b. Vector v equals 2i plus this. Then b, acceleration, that's the component acceleration at time t seconds. 2 seconds in the direction of this. Now, let's just go. We know that component velocity is equal to velocity times or dot the unit vector. And you know that unit vector, in this case now, where they gave it to us as b. So let's use b. That is given to us, b. Let's use b. Unit vector is given as the b vector b over magnitude of b. Now the vector b given to us is 2i plus 4j plus 5k over the square root of 2 squared plus 4 squared plus 5 squared, which means we'll have 2i plus 4j plus 5k over 4 plus 16 plus 25. That's square root of 45. And square root of 45 is 3 root 5. So we can have we have that b, that's this aspect of it, b unit vector is 2i plus 4j plus 5k over 3 root 5, that's square root of 45. Now since we've gotten this, we need to now find velocity. Remember, velocity is giving us differentiating the displacement with respect to time, and r is giving us two, that's in the question, this I, j, and k. So if we can write it, let's rewrite r. So this is r given to us, so we need to differentiate this r with respect to t. Now, which means 3 times 2 is 6, so we have 6t. 3 minus 1 is 2. That is for I. That is for I. For j, t times, well, let's say plus 3 times 1 is 3. So t 3 minus 1 is 2. T 2 minus, here we have 2 times 3 6. T 2 minus 1 1. So we close it. This is for j. Then for k, we have 2 times 1 2. T 2 minus 1 1. There's no need putting the 1. There's no need putting it. Minus, now this is only 4, which is a constant. Whenever you differentiate a constant, you're going to get 0. So this becomes minus 0, and it is k. Now it is at t equals 0. So t equals 2. At t equals 2, we're going to have 6 into 2 squared I plus 3 into 2 squared minus 6 into 2 j, then plus 2 into 2 k. So this is 4 times this 24, so we have 24i. Here this is 4 times 3 12, we have plus 12i, sorry, j, 12j minus this times this is 12 as well, which is 12j, that's all. Now plus 4k. What it means is that we have 24i plus minus 0 plus 0j plus 4k. This is our velocity. Therefore, we can now use so what it means is that the velocity component is this dot this. So this already we got it as this, dot this we got it as this. So we just need to dot them, I and I, j and j, k and k. So having that, 24 times 2 is going to give us 48. So I dot I is going to give us 1. So we have 48 times 1, which is still 48. J dot j, 0 dot times 4 is 0. Let's still include it. J dot j is still 0. 0 times 0 is still 0. 4 times 5 is going to give us 20. So we have plus 20. K dot k is 0. Sorry, yeah. K dot k is 1. I beg your pardon, is 1. So 1 times 20, 20 over 3 root 5. So if we add this will give us 68. 68 over 3 root 5. And since it is in velocity, meters per second, that's our answer, meters per second. The second question said we should get acceleration component. Now, acceleration component, let's use this as acceleration component. We're going to get acceleration itself dot in the direction of b. Let's use b because the question says b unit vector. We've already gotten b unit vector, so let's now get acceleration being with respect to time, which means differentiate velocity with respect to time. Differentiate velocity with respect to time. So having known how to differentiate, you can pause the video and differentiate for you. So this is the velocity that we got. If we differentiate it, we're going to get 6 times 2, 12, t, 6 minus 1, 2 minus 1 will give us 1, so 1 here, I. Now, if we have plus 2 times 3 is 6, t, 2 minus 1 is 1, minus 6, here is 1, 1 times 6 is 6, 1 minus 1 is 0, so anything raised to power 0 is 1, so if I put 1 here, 1 times 6 is still 6, okay, so this is J. Now for K, 1 times 2 will give us 2. 1 minus 1 will give us 0. Anything raised to power 0 is 1. So only 2 here to K. That is what we have. Now where T is equal to 2, we'll have 12 into 2I plus 6 into 2 minus 6 J plus 2. Okay, let's just say K. Now, this times this will give us 24. 24I plus 12 minus 6 is going to give us 6J plus 2K. So write 2K. So this is where we stop at. So this is the acceleration, and it is in meters per second squared. But the acceleration component is giving us the acceleration itself dot the unit vector, which is 24I plus 6J plus 2K dot the direction, the unit vector, sorry, it's 2I plus 4J plus 5K over 3 root 5. So if we dot I to I, J to J, and K to K, what we're going to have is 24 times 2 is 48. I dot I is 1. 6 times 4 is 24. J dot J is 1. 2 times 5 is 10. K dot K is 1. All over 3 root 5. So if you add this, you're going to have that the velocity acceleration component is this 60, 82. You get 82 over 3 root 5 meters per second squared. So please do well to subscribe to my channel, because we also have other formulas that we can use on this depending on what you are asked to get. For example, if you are asked to get force is equal to mass times acceleration, or you can get it by differentiating momentum with respect to time. If you're asked to get momentum is mass times vector over velocity, which is mass into final velocity minus initial velocity. If you're asked to get impulse is giving us integral of force dt. If you're asked to get torque, let's use this as torque. Torque is giving us the position cross force So, and so on and so forth. If you're asked to get work done is force times distance, remember. So, which is force dot dr. The reason we use dot here is because work done is actually a scalar quantity. Torque is actually a vector quantity. That's why we use cross and here dot. So, and so on and so forth. Thank you.